In this slide, let's talk about some of the rules which we store in the DB, right? As I told you, we can have rules based on IP. It can be based on account or it can be based on user base. So we'll just take some samples to understand how they are. So I can have IP-based rules saying slash account slash API slash sign up has 20 recs per minute, which means if I get a request from a particular IP and that request is hitting this URL from a particular IP, account slash API for sign up. So I allow 20 requests in a minute. That is what this means. Similarly, if I hit this endpoint from a particular IP and I just allow only 20 requests per minute. That is how the IP-based request works. Whereas in the account base, I globally classify for a particular domain. So for app.mybooking.service.com, I have 20K requests per minute. At any point of time, I can allow 20K requests in a minute. It could be from any of the APIs, from any of the IPs, so as a global configuration, this is. Similarly, in.mybookingservice.com, this is 10K requests per minute. So this is a global level configuration. This is a endpoint level configuration. So that's what. And similarly for user base, I have a specific use case where I want more throttling for some of the user IDs. They have some extra privileges. So I can say user based in the key value format where it says user ID, count, and start time. So I say Ramesh has max of 4 requests per minute, and in the times start time, this is time timestamp which has been there. So we keep on updating the timestamp so that difference would be always not more than a minute. In a minute, Ramesh always have access to 4 requests. So this is a user base. So we have these different ways where we can configure our rules. I'm just giving you an overview of how the rules can be configured. And then, as I told you already, I choose here limiter as a middleware, which is between client sends the request, then it goes to the ELB or the load balancer, and from there, the rate limiter takes it, validates it, which is the compute at the back, and says, hey, this is allowed request or not allowed. So the primary job of rate limiter is to just say yellow or not allowed. So what algorithm we use, what logic we use behind this, probably we'll discuss, but this is what it does. So it allows to the API servers, the processing happens and the request comes back. If it is not allowed, we just send back with a 4 to 9. That's how this works as a middleware. Going next, the interesting in this entire rate limiting concept is basically the counter. If you have observed, I'm being saying whenever a request comes, it matches your rule in the database or in the Redis DB cache. And if the rule matches, it checks with the counter. It checks with the threshold first. If it is under limit, the counter increases one by one. And ultimately, when the counter reaches the threshold value, we block the request. So here the most important thing is a counter, because that is one of the highest level to track how many requests are submitted from the same IP address or from the same user, and how many should be allowed, how many should be rejected. So these all depends on this counter. So the counter need to perform in a well manner. So how do we store this counter? Where to place this counter? So that is something what I'm trying to illustrate here. So let's assume we are allowing 3 requests per minute for a particular user. So whenever a request comes in, what our rate limiter does basically is it will check first for the user ID. I'm just taking user ID as a unique key. So it first checks for the user ID which is present in the hash table or not. If it is not present, then it just inserts it. That means it's a new request which has come from this particular user. It inserts that and sets the counter to 1 and set a start time to the current time. That is what it does, and simply allows the request. Assume that it already has the user ID. It finds the user ID already existing. Then it tries to find a difference, between current time to start time. The start time is the time which is already registered in the hash table. It just takes the difference. If it is greater than or equal to 1 minute, if that is the case, then which means I still have a buffer under the 1 minute window. I'm there, and it sets the start time to the current time, updates, and count to 1 and allow the request. That is what it does. In case if the current time to start time difference is less than 1, and that means it is more than 1 minute, then and if the increment is already 3, we are allowing only 3 requests per minute, If it is greater than 3, sorry, if it is less than 3, it will allow the request. If it is greater than 3, it rejects the request. So the entire logic depends on this counter over here. So this is how I'm just trying to give you the flow. Okay, 1 second. So if you see the request has come at 3 a.m. So we just inserted into the hash table. Ramesh is a user, count 1, start time. Now I got a request at 3 of 10 seconds. We just increase the count to 2, update the time. We just keep the start timestamp, and we just allow the request. Now, if you see of 3 of 1, which is after 1 minute, we just reset the count and update the start time. Just reset the start time also because there's a change in the time block. So we say this is the start time now. And the count is reset to 1 and it's allow the request. Now let's say 3 of 1 at 20 seconds. We just increase the count, the start time remains the same in the same 1 minute window it is, and we still allow the request. And 3 of 1, 45 a.m., 45 seconds, we see the count, it's still 2, so we allowed it. So we have count is 3 and now the start time remains the same. Let's say at 3 of 1 at 50 a.m. Okay, we said only 3 requests are allowed. At 50 a.m., which is within the 1 minute window block, we see the count is already 3. Hence, we can't allow this request and we just reject the request. Right? And let's say we get some other request at 3 of 2, which is after the next 1 minute window, then the counter will reset basically to 1 and the start time gets updated. So this is how the entire flow happens. This is a simple fixed window flow. We call this algorithm is basically called as a fixed window flow. We probably will not deep dive into this algo, but this is a basic algo which works in one of the algo which works in rate limiting approach. So here entire flow, what I'm trying to say is the counter is quite important. So where do we store this counter? I'm saying again, the counter is quite important for the entire logic. Where do we store? So we need to decide or think of a place where I can use time-based expiration techniques and we have in-memory cache available. So basically, wherever these two I have, it's a better place to store the counters, and naturally, Redis is my best choice because we have INCR command where the increment can be done automatically, just +1 without any much computation. The expire command, which I can use it to set the timeout for the counter. Counter automatically gets deleted, once the timeout expires. So these two are some other use cases where I feel Redis is the best choice to choose to store the counter. Now, as I told you, to implement this, the major algorithms we see is token bucket, leaky bucket, fixed window counter, sliding lock, and sliding window counter. In this, I'll take sliding window counter as an example, and I'll deep dive. Probably I'll also go through the sliding window algorithm, and then I'll take the sliding window counter algorithm to understand the difference, what is the impact, and then slowly we'll try to see the implementations.